Alright guys, so yesterday we got started a little with some trigonometry, right? Sine, cosines, tangents. Okay? Now, this is not a geometry class, so my goal is not to give you some very difficult triangles and make you use all the different trig identities and Pythagorean theorem and all that stuff. Okay? My goal in this class is to teach you the geometry that we need to do the physics we need to do. Okay? Because I realize some of you are at the point where you've taken integrated geometry and you know SOHCAHTOA stuff, right? Others of you are at the point where you haven't taken this part of integrated geometry, so the SOHCAHTOA stuff is all new for you, right? Some of you might have learned it on your own, so it's not new anyway, all right? So we're all at different points in terms of SOHCAHTOA, so I'm going to teach you what we need to know for this class, okay? All right? So the whole idea of SOHCAHTOA, right? Those are trig identities. The S stands for sine. O stands for opposite. H stands for hypotenuse. C stands for cosine. A is adjacent, right? T is tangent. We already know what H is. That's hypotenuse, okay? So here I have a triangle with 3 different colors, right?
Yes, sir.
Now, the purple one, last hour told me it's purple. I thought it was black. Okay, the purple one is the what for this triangle? The hypotenuse. Okay, one thing I forgot to draw in here, actually Prezi doesn't really let me draw it, is that right angle piece right there. Okay, so the purple one is the hypotenuse. Okay, now for our class, we're going to be talking about vectors and components of vectors, mainly velocity vectors. So this purple part is the hypotenuse, but it's also the vector. It's the initial vector. Okay? The initial velocity vector. Now the blue parts is x. Okay? It's horizontal, right? It's also adjacent to our angle. Now you might not be able to see this angle right here. It's yellow on the Prezi. But this thing right here, that represents our angle, right? Now what variable do we give to angles? What symbol? Theta. Right? Right? A 0 with a line through it? That theta looks terrible. What should I get? There we go. Okay, that's a better theta. Alright, so that theta is a variable meaning angle measures, right? Okay, so we said the blue one was our horizontal. What's the red one then? Vertical, right? It's the vertical component. It's the y direction, Kevin. Okay. So in this class, we're going to be in this unit, unit 4, which you saw at the start of the slide a second ago. In this unit, we are going to be spending most of the time working with velocities. So this is our initial velocity. Okay. This blue line is our velocity in the x direction. Okay. This red line is our velocity in the y direction. Okay. Does that make sense? Does that make sense, guys?
Yes.
Okay. So now we can call these components of our velocity Vx, Vy, and V. V's are our original velocity, Whitney. Vx is the horizontal component. Vy is the vertical component. Right? Does that make sense? A Vz? No, we're not going to work in 3 dimensions. Okay, but if we did work in 3 dimensions, there could be a Vz. Well, I guess I should say we are going to work in the time dimension. So we are working in 3 dimensions, but not Z, not X, Y, Z. X, Y, and time. Okay? Alright. What I want you guys to do, because like I said, this is not a geometry class, this is a physics class. I want us to figure out some equations for Vx and an equation for Vy in terms of theta and V. In terms of our angle and the velocity vector or the hypotenuse. Right? Does that make sense? So, let's find an equation for Vx. If I want to find an equation for Vx, and I want to use V and theta, right? Vx is right here. Should I use sine, cosine, or tangent? Cosine, right? Because this is adjacent to theta, isn't it? It's next to theta, right? Right, phone? Okay. So, phone. Okay. So I should use cosine, right? Okay. So I know cosine theta equals opposite, or not opposite, my bad, equals adjacent, which is Vx, over hypotenuse, which is V. Now, if I'm going to solve this, and these are vectors, sorry. If I'm going to solve this for Vx, what do I have to do? Multiply by V. Okay. So then we know Vx equals V cosine theta. So what that means is if I know my velocity V, right, and the angle that velocity is launched at, the angle of initial velocity, I can find the horizontal component. That's how fast it's going parallel to the ground. Yes?
You wrote that in a very bad glare.
I wrote it in a very bad glare.
Oh yeah, they could sign up.
Better?
I'll write down.
Good? Okay. Alright. When I turn the projector, I'm going to give us a little lighter too. Alright? Alright. Any questions about that? Alright. Now in the y direction, I want to find one for our vertical component. Right? Y is opposite. Hypotenuse is V, right? So should I use sine, cosine, or tangent? Sine. So we know sine of theta equals Vy over V, where these are still vectors, right? Multiply by V. So we get Vy equals V sine theta. Okay. Does that make sense? You guys, does it make sense how I got those?
Yeah.
Okay. If the sine cosine stuff doesn't make sense because you haven't taken geometry yet, that's okay. But does the algebra make sense? That's kind of more of what I'm getting at. Now, sine, cosine, and tangent only work for right triangles. So some of you are probably thinking, what about law of cosines, law of sines? I need to know that. And the answer is no. You do not need to know that. We're only doing right triangles because x and y are always perpendicular. Horizontal and vertical are always perpendicular. So we're always going to be doing the right triangle. Okay? Now the last thing, because this is the right triangle, what's one more equation we can come up with? Pythagorean theorem. Pythagorean theorem tells me that. Good. So those three equations are helpful. Remember, V is the initial velocity, okay, or the length of the vector. Vx is the x components, the velocity in the x direction, the velocity that's parallel to the ground. Vy is the vertical component, the velocity goes up and down. Okay? Does that make sense? Yeah? Any questions? Any questions?